If you want to release a new version of your application in Kubernetes, most people will tell you to install service mesh or a rollout controller. But what if I told you you can do the canary releases and the instant rollback only using the Gateway API? So I'm going to hit the same endpoint multiple times and you will notice the different version is responding every time. That traffic split is not random. It's not happening in the browser and it's not handled by the application. It's handled by the gateway. This is progressive delivery without introducing new moving parts. If this feels like magic, don't worry, we will rewind it. In the previous video, we deployed an application, exposed it using Gateway API, and traffic is flowing normally. Now we will evolve that setup without breaking anything. So let's start by deploying a newer version of an application. But before that, let me show you the existing application which is already running on this particular cluster. So if I run kubectl get pods, so this is the API and the front-end application which is running, and we have a services for that. So these are the services, that is the API and the front-end, and we have also configured the gateway. So kubectl get gateway, and the gateway is already there and it's working fine as well. So now if I get the HTTP route, so kubectl get HTTP routes, so routes is also there. So let's try to access this application. And we can see our application is working fine. And if I run the another endpoint, both the endpoint is working fine. Now we got a requirement to update the application front page. So for that, let me deploy the newer version of the application. So the first rule of safe rollout is deploy first, route later. So that's why we are deploying the application first and setting up the routes later. So we do not touch the existing deployment here. We will add a new one. So for that, I have already created a manifest files. So if I open apps2.yml, so this is a deployment file for the front-end application with a version 2. If you notice the difference, the version 2 is updated here. And if you come to the labels here, this is a version 2 label. This label is critical. It allows us to target version 2 independently. So no traffic is hitting this yet. This pod is completely safe as of now. So let's apply this manifest file. So kubectl apply -f apps2.yml. So the deployment got created. If I run kubectl get deploy, we can see the deployment got created with a version 2. And if I run kubectl get pod, here we can see the pod also got created. But the gateway API does not route to the pods. It routes to the services. So let's create a service for the same. So I have already created a services file as well. So this is the service file for the front-end application. So this service selects only the version 2 pods. So let's apply this manifest file. So kubectl apply -f service2.yml. So the service also got created. If I run kubectl get service, we can see the front-end service version 2 also got created. So now we have both services and the pods running. So here the version 1 and version 2 are completely isolated. So the front-end service of version 1 is routing a traffic to the front-end pod of version 1. And the front-end service of version 2 is routing a traffic to the front-end pod of the version 2. Now both the version exist but with the zero risk because we haven't changed the routing yet. So most teams stop thinking here. They update the service selector and the traffic flips instantly. If something breaks, user is the first one to find out the issue. But we are not doing that. Instead, we move traffic slowly. We are going to split the traffic between version 1 and the version 2. So in the Gateway API, routing decision belongs to the HTTPRoute resource. So I have already updated the file. So let me show you very quickly. So this is the file. So this is the HTTPRoute manifest file for our application. So if you are not aware like how to create a HTTPRoute file, do check out my Gateway API tutorial. You will get a better understanding about the same. So for this particular demo, I have already updated the section for the front-end application. So here in the front-end path, you can see I have added the match references and the path prefix. And below that, I have a backend references. Earlier, we were having only one, that is a front-end service. Now I have added the another one, that is front-end service 2. Which we just created, and it's also having the same port, that is port 80. But here if you notice, I have added one more field, that is a weight. This is the percentage based routing. In the weight we are giving a 80 here, and the below service version 2 we are giving a 20% over there. So over the time traffic is statistically split between the applications. As of now I am giving 80% to the front end application, that is a version 1, 20% to the service 2, that is the version 2 application. Let me apply this very quickly. kubectl apply -f canary routes.yml. So the route got configured successfully, and if I run kubectl get routes, sorry, it's HTTPRoute. If I describe this, kubectl describe HTTP routes and the routes name, and if we go up, and here we can see the weight got applied to both the services. So now let's verify it very quickly. So this is our application which is already running. If I refresh it, so if you notice, it's showing it from the version 2 application, because if you see, this is the pod name which we just deployed. If I come back here and then kubectl get pods, so front-end deployment v2 is the version 2 application. If I refresh it again, now it's showing up the version 1 application. If I refresh it again, it's version 2. Now it's version 1 again, because I gave a 80% to the version 1. So that's why most of the time we are getting the version 1 application. So some requests hitting version 1 and some are hitting version 2. This is a production grade traffic splitting. If this metric looks good, we don't deploy again. We just adjust the number. So if I update the HTTP route again, and I want to change the numbers to 50-50 now, because now I want like more people will see the version 2 application. So if I save and exit, and let's apply this. Now it got updated, and 50% user will getting the version 2 and 50% will get the version 1 application. If we are able to see like our version 2 is working fine, we can completely cut the version 1 application and fully route the traffic to the version 2 application. So if you notice, there is same gateway, same route, but a different behavior. But in case version 2 misbehaves, we don't need to redeploy the application. We just need to set the value to the 0 in the HTTP route manifest file, and the traffic immediately goes back to the version role, and this rollback takes only seconds to complete. Let me pause for a second and name what we just did. When we moved traffic gradually, that was a canary rollout. When we flipped everything at once, that's blue-green. Same gateway, same route, just a different decision. And the important part is, we didn't install anything new, we didn't change the application, and we didn't add any new control plane. All we changed was routing. This is why Gateway API matters. Routing is declarative, rollouts are controlled, and application stays boring. Ingress mix routing, behavior, and rollout logic together. Gateway API separates it cleanly and predictably. This is how platform teams think. At this point, we have implemented blue-green, instant rollbacks, and the canary releases, all by using the Gateway API only. If you found this helpful, hit like, share it with your friends, and subscribe for more content like this. Thanks for watching. I will see you in the next one.